Hello and welcome to the last section that we are going to do in chapter 10. 10.5 is called Permutations and Combinations, and you might want your calculator handy for this section. So we're not going to fully do the explorations, but I want to look at this first one. So you're going to flip 2 coins and spin a spinner, and the spinner has 1, 2, and 3. And so we have 2 questions. How many outcomes are possible, and to list the outcomes. So if we look at the levels of this diagram though, so the top level here, that's the first coin. So the first coin can either land on heads or tails. Then this level is the second coin. So it doesn't matter if the first one was heads or the first one was tails, the second one can still be heads or tails, and the third one can be heads or tails. The last level is the spinner. Okay, so you could get like heads, heads 1. Or heads, tails 2. Okay, so how many total outcomes are possible? So if you count all the branches, you have 1 branch, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 branches. So we want a method though that we don't actually have to count every branch. So there were 2 options for the first coin. You're either heads or tails. There's 2 options for the second coin. It's either heads or tails. And there was 3 options for the spinner. So can you maybe think of a way to take 2, 2, and 3 and turn it into 12? Maybe you thought, hey, if I multiply them together, you get 12. And that is actually how you do it. It's called the fundamental counting principle, I believe, and you just multiply your options together, and that gives you your total amount of options. Now, list all the outcomes. I'm not going to list them all, but it would be like heads, heads 1, heads, heads 2, okay, etc. there. So the question is, do I really need to, are these 2 heads different? And yes, they are. It's different in the fact that this is heads on the first one versus this is heads on the second one. Okay, and that is different, and that's kind of what we're going to talk about today. So I want you to look over at your definitions, and the first definition is for a permutation. And a permutation is an arrangement in which order is important. An arrangement in which order is important. So the number 1 example I can give you for this is what you call your locker combination, right? That is actually a permutation. You have 3 digits that you spin your little dial or whatever on your locker to get into your locker, and the order matters. Whatever number I put first, whatever number I put second, whatever number I put third, that order matters. Your locker has a permutation. Spelling words is a permutation, right? It has to have a certain first letter and a certain second letter. Let's say we were going to do class officers. Right, and the first person picked gets to be the president, the second person picked gets to be the vice president, third person picked gets to be the secretary. In this case, order matters. What position you were picked in, right, is which office you have. So a permutation, order is important. So next we're going to look at ways to figure out permutations. Before we get to the bottom with the formulas, we need to stop at factorial. And you may or may not have heard of factorial before, but you might have seen the button on your calculators. If you have ever seen the exclamation button on your calculator, so in this case, if we did in factorial, factorial means to start, let's say for n, you're going to start with n, you're going to multiply it by the next number down, times the next number down, times all the way down until you get to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. Instead of actually multiplying those all out, if you can find the factorial button on your calculator, you can just do 5 factorial. If you have a graphing calculator, that is under math, and then go over to probability, and it's number 4. Okay. If you have another calculator, come to one of our live sessions and I'll help you out. So that is what factorial is. 32 factorial is 32 times 31 times 30 times 29 times 28 all the way down to times 1. So we have two kind of different ways that we can find permutations. The first one here, so I want you to look at this notation. This is a permutation of n objects taken n at a time. So if I had 5 letters and I want how many different arrangements can I have for all 5 of those letters? This goes back to the 2 dice in a spinner. You would go 5 times 4 times 3 times 2 times 1 because, right, if I have 5 letters, let's say we have A, E, I, O, and U. I got 5 letters. How many options do I have for the first letter? I have 5. Well, that takes out one of them. So how many options do I have for the second letter? 4. How many options for the third letter, the fourth letter, the fifth letter, and then you are going to multiply them together. Okay, and that is your factorial. Now, the second one we want to look at here, so here, make sure that you circle that in your journal. The second one we're going to look at here is n objects, but only taken r at a time, where r does have to be less than n. So maybe I have my A, E, I, O, and U, but I only want 3 of them. So how many options do I have for the first one? I have 5, then I have 4, and then I have 3, and you're only going to multiply that together. That was 120. This one down here is 60. So to figure that out, right, you could actually always subtract the end that I didn't want, kind of in a sense. Or you have this. So you have n factorial over n minus r factorial. And so you would take the difference. So in this case, it would be 5 factorial. Let's look here with our 5 letters. 5 factorial over 5 minus 3, which would be 2 factorial. And so that is 120 over 2, which is your 60. Or you can look at it, it's 5 times 4 times 3 times 2 times 1. There are times between all those. Over 2 times 1, and the 2's cancel and the 1's cancel, and you just have that part. Now, your calculators, most of your calculators will do permutations for you. I just can't remember how to tell you off the top of my head, but if you can show me a calculator, I can show you how to use it. So before we get into our extra examples, we do need to talk about combinations. And a combination is something where order is not important, right? So I'm going to pick 3 people to be class leaders for the week, but it doesn't matter which order you're picked in because you're all just a class leader. It's not like president, vice president, secretary. So if order is not important, right, if I'm looking at like A, E, I, O, and U, and I want to pick 3 of these, you know, A, E, I, and A, I, E are the same thing because order is not important. Okay, we're in a permutation, those would be considered different. So here, if we look, I'm going to take n objects, and I want the combination of taking r of them at a time. And r can be equal to n, that's fine. So you're going to do n factorial over n minus r factorial with a times r factorial. So it's the same, like this part over here is the permutation one. We just have this extra times r factorial on the bottom for a combination. So if I have 4 objects and I want to take them 2 at a time, okay, so here are my 4 objects, taking them 2 at a time. The top is n factorial, which is 4. Here's my n minus r factorial times r factorial. And if you look, we can do some crossing. We could either cross those out or you could actually have crossed these out. And your answer then would be there are 6 options, 6 different combinations of 4 things taken 2 at a time. So let's look at our extra practice. So for number 1, we have $2,564,783. And we want to find the number of ways you can arrange all the numbers. So here, order does matter. So this is going to be a permutation. So for A, it's all the numbers. So here we have 7 numbers. So I have 7 numbers. Let me switch back to a pen here. All right, I have 7 numbers, and I'm doing the permutation of taking all 7 of them. and that's going to be 7 factorial. 7 times 5 times 4 times 3 times 2 times 1. And that is going to be 5,040. Now for B though, I have 7 numbers, but I only want to take 3 at a time. So looking at your formula, that's going to be 7 factorial, your n factorial over n minus r factorial. Now, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm going to leave that as 4 factorial. The bottom, 7 minus 3, is 4 factorial. And then you get to cross out your 4 factorials if you want to. And you get 7 times 6 times 5, which is 210. So why don't you pause and see if you can do number 2. All right, hopefully for 2A, if you have 10 objects, taking them 10 at a time, you did 10 factorial, so 10 times 9 times 8 times 7 all the way down to times 1. You got 3,628,800 options. That's how many different possibilities there would be to rearrange those numbers, that many possibilities. So in a place like Sonic says we have so many drinks, or Subway says we have so many options of sandwiches, that's what they're doing. All right, so if you have 10 objects though and you're only taking 3 of them at a time, you did n factorial over n minus r factorial, which gave you 720. Your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD. How many possible ways could the 5 songs be ordered? So when you're reading these, you just really need to make sure you're looking at, is order important or not? So here, order is important. So I have 9 songs, and I want the permutation of taking 5 at a time. That's going to be 9 factorial over 9 minus 5 factorial, which would be 4 factorial. So I'm going to do 9 times 8 times 7 times 6 times 5, and you get 15,120 options for those 5 songs on your CD. All right, let's look at number 4. A witness at a scene of a hit-and-run accident saw the car that caused the accident had a license plate with only the letters I, R, L, T, O, and A. Okay, but we don't know what order those letters were in, so we want the probability. This is the first one we've done that's asked for a probability. Everything else is just asked for a total number of outcomes. Find the probability that the license plate starts with a T and ends with an R. So there's 6 letters here. So let me draw that out here. We have 6 letters. All right, so we want the probability. The first one is a T and the last one's an R. So I'm going to go ahead and put those there. So the first thing is, how many total options are there for these 6 letters? So that's a permutation. So we're going to have 6 letters, permutation, 6 at a time, which is going to be 6 factorial, which is 720. Okay, that's our total. So remember, probability is favorable over total. So favorable would be that the first one is a T and the second one's an R. So there's not options for that. But for the rest of it, like we have 4 in here that can be anything, right? So you're going to have some combinations of those other 4 letters. So that's going to be 6. We had 6 letters total, right? Oh, hold on. We're down to 4 letters. Right? We took out 2. We have 4 letters total, taking 4 at a time. That's going to be 4 factorial, which is going to be 24. Okay, so our probability, so this is favorable. This is favorable. Because favorable is T and R are where they're supposed to be, and there's 24 other options out of the 720 options. And if we reduce 24 over 720, we should get 1 out of 30. That's how you do that one. All right, so those have all been on permutations. So number 5 here is on combinations. How many possible combinations of 3 colors can be chosen from the 7 colors of the rainbow? Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. So red, orange, yellow, and orange, yellow, red, it doesn't matter. They're the same combination, okay? So referring back to your formulas, we're going to have 7 colors. Combination, we're going to take 3 of them at a time. On top it was n factorial, which is going to be 7 factorial. N minus r factorial, 7 minus 3 factorial, times an extra r factorial. So if we look at that, and you can do it all in a calculator if you want to, or you can look at the fact that some of it crosses out if you want to. I'm just going to put it all in my calculator here. 7 factorial divided by 4 factorial times 3 factorial, and your answer should be 35. All right, that is what I have for you today. Let me know if you have any questions, and have a good day.